Okay, on to question 6. Calculate the magnitude of the resultant force on the firework. Okay, so you can see we've got thrust upwards and weight downwards. Now, I don't like their forces diagram very much because you can see that those two arrows are the same length. Okay, whereas actually the force arrow should be really, really tiny compared to the thrust because the thrust is much, much larger than the weight. So it's going to accelerate upwards. Why? Because there's a resultant force upwards, and the way that we work out the resultant force is we take the larger force and we subtract off the smaller force. Okay, and it's so that's 26.4 newtons upwards because it's always in the direction of the larger force. But you can see here it's just asking us for the magnitude, which is the size of the force, so the correct answer is 26.4. Set the formula linking resultant force, that's sigma F, and mass times acceleration. Hopefully you know that, but again you can check that using the formula sheet if you need to. The mass of the firework is 160 grams. Okay, now hopefully you'll remember that to be able to use in this equation we need to convert that into kilograms. Okay, and how do we do that? Well, there's 1,000 grams in a kilogram, so that means we need to do 160 divided by 1,000, and that will get us 0.16 kilograms. Okay, so that's going to calculate the acceleration of the fireworks. So again, I'm going to use my formula triangle to help me to rearrange this. Okay, I'm going to cover up A with my thumb, and that leads me to sigma F over M is the correct rearrangement there. The resultant force you worked out as part of the previous question. Okay, and the mass we've just worked out together there. Okay, and that means that you should get an acceleration of 165 meters per second squared.